Hi, how are you?
Good.
Good.
Is my sound echoing? Is the audio bad?
No, I can hear.
Okay.
Yeah.
I have an external speaker hooked up, so I didn't know if it was gonna make it echo.
Well, then just go to bed. Good night.
No, I can hear you pretty good.
Okay.
Okay, go to bed. Okay. Hi.
Hi, Annie.
Hey. Hey. Go to bed. Sorry, I really just put them all to bed. She always gets up again and again and again. So.
Yeah, there's always one in the crowd.
Yeah, she has a lot of energy. She's a baby.
Well, she just wanted to say hi.
Yeah, I think so. How are you guys doing?
Good.
You know,
Maritza, did you see my...
What?
Oh. Did you see my comment, Maritza, about the exam, about next week? I looked at next week and it's all a review.
Oh, no.
Because you had put that question, like, are we going to review? No, it was on the, you put a comment, like, on the website, are we going to have a review?
Oh, yeah. Uh-huh.
So I replied to that, because next week it looks like it's all review.
Oh, good.
There she is.
Yeah, I was hoping that there'd be some reviewers.
This is my Julia.
Hi, Julia.
He said wait for 20 minutes.
Daddy said wait for 20 minutes? Okay, go read your book.
I'm hiding in my room to be where you sleep.
Okay, hey. It's actually really early for them to go to bed. So.
It's so cute.
Like, I've noticed that I do this at 7:30, so we don't really do scripture study, and then I'm in here, and then they're in here trying to, like, nobody puts them to bed, so I'm, like, thinking, I gotta put them to bed before I start this.
Yeah.
You're messing with the schedule, Annie.
I know. Last week, I don't think they went to bed till, like, 9 o'clock or 9:30 or, oh. Anyway.
Does it help you to have both of these on Tuesday nights?
Yes. I think so. Next Tuesday, my one daughter has a choir concert at the same time, but...
Do we want to switch it to doing both of them on Thursday night? Oh, we can't, because it's due on Tuesday.
Yeah, it's okay. I don't know how to get around it. It's okay. Unless we change to Monday. We usually do family home meeting on Friday or Sunday night.
I don't mind meeting on Monday.
No?
I'm okay with Monday. All my kids are gone.
I wonder if Julia would have, maybe she has like a family home evening group or something though, so I don't know. Whatever, if it doesn't work out, it's fine. It's what it is, so.
Well, we'll try it. It's okay with me.
Okay. No, it does help. And I think when the time changes, we could probably change to like, I think we'll be on the same time, everybody?
I think
right?
so. Well, no, they're still an hour. The Utah, Idaho folks are still an hour. Well, you will be, I think, in Arizona.
Isn't it November 1st?
I think so.
Yeah, I think so too.
So like it's 7:35 here.
Yeah, same with me.
And how about you, Maritza?
I'm in Provo.
So in November, doesn't it go back an hour? So you'll be the same time as us, right?
I think so.
Yeah,
Arizona doesn't switch, but Washington does.
Okay.
Oh. I wonder where Julia is.
I'm not sure.
It's weird. How did the homework go for you guys this week?
I like struggled with some of them. Yeah.
did initially. Like I read through it, and then when I watched the videos after I read it, it made more sense.
Do I think sound is echoing now?
What?
I think your sound is echoing too.
Yeah, I turned my external speaker off because it was echoing.
Oh, okay.
So we shouldn't have any more trouble with it now.
Okay.
Okay, let me see. Oh yeah, it's gone. Okay. I hate that when you're calling somebody and you just keep hearing yourself.
Yeah, it's really annoying.
So annoying.
Well, we want to get started, and then Julia can, I'm sure she's just racing back from the hospital, so we can get started. And, you know, we haven't been having an opening prayer, and I think that would be a nice thing.
Yeah, that's a good idea.
I need all the prayers I can get with biostatistics, so.
For sure.
Yeah, same here.
Does anybody want to give one?
I will.
Thanks.
Dear Heavenly Father, we're grateful to be able to meet together in this technological age and help us to help each other to understand what we need to so that we can gain a foundation in the statistics class, and that we will learn through the Spirit and through our work and efforts. And we say this in the name of Jesus Christ, amen.
Amen.
Oh, I just got your text. Okay.
Yeah. Okay, so we haven't been I haven't been keeping very good track of who's doing the lead student thing each lesson. So maybe we should set up some sort of a schedule, because I don't mind starting the Hangouts on air. I've got it down now.
Yeah.
And my internet seems to work just fine, and I can get onto YouTube and get the URL and post it and all that stuff. I don't mind doing that each week for the group, but we can then rotate from person to person who's going to be the lead student.
Okay.
So,
Sounds good.
I can't remember who did it last lesson. It seemed like, was it you, and then Julia took over because you weren't feeling well?
Yeah. Yeah.
So,
I think it was, I think that's what I remember.
Oh, I thought your camera wasn't working, so we couldn't see you or something.
Yeah, there was that too.
I didn't know you weren't feeling good, though.
Yeah, I just moved to Utah, and I got, I think it was the climate change that affected me.
That's right, you weren't feeling good. You remember? I should remember.
Yeah, I was coughing really bad. Bro.
Okay.
Yeah.
So for lesson 6, why don't we just start? I'll do lesson 6.
Okay.
And Annie, if you want to do lesson 7.
Yeah.
And then we'll put Julia on lesson 8 and Maritza on lesson 9.
Sounds good.
Well, like next week's going to be a review, but I guess that will still be a lesson, huh? Yeah, never mind.
Yeah, because we still meet with our groups.
Yeah, we do. But yeah.
Yeah.
Wasn't sure if it was called a lesson or it is. Sorry. Sorry.
Okay, so let's go with that rotation for the lead student, and I can text that to everybody so we have it.
Okay.
Julia says she's coming.
Oh, good. Okay.
Got it.
Okay.
I'm so sorry, guys.
Hey!
Julia.
I figured you were racing back from the hospital.
Yeah, it's been kind of a crazy day.
Yeah. I just got back from Provo yesterday.
All right. Be careful.
That's awesome.
I'll be back.
It was fun. I got to go to a BYU football game on Friday night with my son.
Oh, nice.
Oh, that's awesome.
So cool.
Very fun. And then we went to the morning session of conference.
Oh, even better.
Yeah,
This conference was so amazing.
it was.
Really good.
Okay, so Julia, we just decided that I do have the Hangouts on Air thing under control now.
Okay.
And so I'm happy to start it up every week, and I have no trouble getting into YouTube and getting the URL and posting it to the group thing. So I can handle that every week.
Okay.
But we were going to then rotate the lead student role, and so we decided that it was that I'll start on lesson 6, and then Annie's going to do lesson 7. And then if you could be the lead student for lesson 8, then Maritza will do lesson 9. Is that okay with you?
Yeah, that's fine.
Okay. So I'll text that schedule out to the group, and then we'll all know when we're in charge of that portion.
Okay.
Okay, so lesson...
We have opening prayer.
Oh, yeah, and we decided to have an opening prayer.
That's a really good idea. That's a really good idea.
All right, so then lesson 6. Did anybody have any questions on part 1 that they want to go over?
I'm good.
I'm good on part 1.
Yeah, I'm good too.
Okay. So when we get to part 2, then we did that funky little randomly select 5 salaries out of your group. And I put mine in a little box and shook it up and picked out 5, and so my distribution the first time I chose was way low. The mean was 38,690 the first time I did it. It was like way low. And so I did another 5, and it was more normal. It was like 45 something. So what was the mean of your samples? You want to start, Annie?
Yeah, mine was 49,560.
49,960. Okay.
What was yours again? Sorry, I didn't write it down.
Mine was 38,690.
690?
Yeah.
Okay.
So, Julia, what was your mean?
I was able to do the rest of part 2, but I didn't get the chance to figure that part out. So I don't have that part done.
Yeah, I thought we were gonna do that as a group, so I didn't. I just waited to do that.
Okay. Do you have your little pieces of paper, or did you want to do the computation thing, or?
Yeah, I have the pieces of paper.
Okay, so just pick out 5. And then you just add up your 5 salaries and divide it by 5.
Okay.
And then you can tell us what you get.
Okay.
Are you leaving, Meg? Oh, okay. My daughter and son are going to go hike on Mount Rainier tomorrow morning, so I was just going to say goodbye.
Oh, I love to hike.
Yeah.
I love it.
So I just add them all together?
Yeah, so add your 5 salaries together.
And divide by 5?
And then divide by 5 and tell us what you get.
I got 42,940.
Okay.
42,940. What was yours, Annie?
Mine was 49560.
49560. Okay.
It's homecoming week here, so my 16-year-old just went to movie night. They're doing Back to the Future.
Oh, fun.
Yeah, that's kind of cool. 8 o'clock.
It's going to be a late night.
Mm-hmm. Yeah, for a school night, too.
Yeah.
The younger people can go without less sleep than us. I used to do that, but not anymore. I'm tired.
My roommates all call me grandma because I go to bed at like 10:30. But I'm like, well, you have to get up at 5. You go to bed pretty early.
That is not early.
Yeah, and it's not, 5's not bad, but.
No, I mean, 10:30 is not early.
I
I said wake up at 4:40 to go to work.
Oh, man.
Mm-hmm.
Okay, so you're supposed to find a meme of all of those as well.
I don't think so. What did you get for your meme, Julia?
It's a little high, I feel like. I think I'm like added an extra 0 somewhere. So I'll do it one more time.
Okay.
Oh, I think we're just supposed to talk about the differences.
Okay.
Right.
Yeah, mine's pretty high compared to your guys's, I feel like.
What'd you get?
It's 49. No, yeah. But what was your guys's again? Sorry. So, oh no, Annie's was 49 as well. So mine's 49, but 900.
Okay.
That's fine.
Yeah.
4,900.
So then on B, it says the graph illustrates the sampling distribution of the sample mean. There are 142,506 possible combinations of the 30 salaries drawn 5 at a time. This graph represents the distribution of all possible samples. Make a mark on the horizontal axis to indicate the value of your sample mean from part A. So yeah, it's kind of interesting if you mark all of ours. It does they all fall in that area.
Mm-hmm.
And Annie's and Julia's are pretty close to the mean. I think if we kept doing this, we would find that we would get that same distribution.
Yep. If only there was some more time in the world.
Yeah, no. That little tool that they had us using, I was only doing a few, but when you watch the video and he hits he's hitting the button and they fill in, that's, a lot easier to see a trend than...
Mm-hmm.
Oh, yeah.
I think they're instructing... uh-oh, Julia's gone. Huh. You want to text her, Maritza, and tell her... Oh, there she is.
Okay.
It's been one of those days.
Oh, man.
I think the instructions they gave us on using that little tool didn't tell us to keep, hitting the button like he did in the video. I didn't feel like I got the same result.
I thought it did. I thought it said keep hitting the animate and then 10,000, 10,000.
Oh.
I don't know. I couldn't even get it to work for me because I was doing it on Internet Explorer. It took me like an hour to figure it out. And
oh, no.
I know, that was a waste of time. And then finally my husband came and opened it up on Chrome and it worked. I'm like, whatever. Really annoying.
Okay, so let's see. C, 7C. Does your sample mean appear to be unusual? Explain what you think it is or is not unusual. I thought mine was unusual because it was so low.
I'm having camera issues. Okay.
How can you tell if it's unusual or usual?
Are we talking about C?
Yeah, I think
Okay.
the standard deviation, if it's less or more than in the 95 percentile, the 95%, then it would be considered unusual. Isn't that right? When it's more than 2 standard deviations out either way, then it's considered.
Oh yeah, I forgot about that.
Yeah.
Okay.
I was thinking something else, but I think you're right.
Okay. So I would say mine is unusual, but the rest of them are all not unusual. They're all within that section, that 95th percentile area.
Okay. Yeah.
Okay. Compare your mean from question 8A to the means obtained. I think they meant 7A. They mean 7A.
Yeah.
Compare your mean from question 7A to the means obtained by at least 3 other individuals. What do you notice? In practice, you only get to see the means from the samples you draw. You do not get to observe any other mean that could have occurred. So I just think it's interesting how all over the board they are. And if they just went on mine, if I just got my sample and thought that was, the norm, then that would be odd. I think just having the ability to take enough samples that you get a nice distribution is better. But they were talking about how you often don't have the money, that luxury of the budget to do that many samples. So do you guys have any thoughts about that one?
Are we talking about D still?
Yeah.
Oh, yeah, I was going to say, I guess it would probably go with that rule, like if there were more than 30, like if there were 30 of us in a class and we all put a number, it would probably look closer.
Yeah. The distribution would be more evenly distributed.
Mm-hmm. Okay.
All right, number 8. The Graduate Management Admission Test, GMAT, is used as an admission criteria in many Masters of Business Administration programs. The scores on the GMAT are normally distributed with a mean of 529 and a standard deviation of 113. Consider a simple random sample of 10 students taking the GMAT. What is the shape of the distribution of the sample means for all such samples? So, because parent population is normally distributed, the sample means would be normally distributed, right?
Yes.
Yeah. Mhm.
So how do you know that the distribution of the sample mean has this shape? Because the parent population is normally distributed.
Righto.
Okay, C. What is the mean of the sampling distribution of sample mean scores for all such samples? And the sample mean was 529, so that means that the sample mean for all the samples is also 529. That was one of the rules, right?
Yep.
Then D, what is the standard deviation of the sampling distribution of the sample mean scores for all such samples? So do you remember the formula? It's the standard deviation is, so it would be 113 divided by the square root of the number of samples, which was 10. So 113 divided by the square root of 10 gives you 35.734. Did anybody get something different or not understand it?
You know what I noticed? I got basically the same answer, but depending on how they want us to round, I could be different on those lower decimal numbers. Does that make sense? Like when I first did this, I got 35.736. Then I saw the answer key, it was 734. So then I figured out how far I had to put in my calculator when I divided to get that.
Mhm.
Anyway, I just find that confusing. Because
The more put in was to what they had.
One thing I had to do with the calculator was make sure that you follow the algebraic function rules so that you're doing things in the right orders. And
oh, yeah. Yeah, no, I was doing it. But like I was just dividing this, it doesn't even really matter, but I was dividing 113 divided by 3.162 originally. And when I did that, I got 35.736.8. Okay? But so then I changed it and I divided by 3.1623 because really I was supposed to put that 2 to a 3. And then I got the right answer. But that's 4 decimal places over, so I was thinking it was always 3 maybe.
Well, that's kind of what I mean, though, is that on the calculator, if you do 113 divided by, and then you do the number 10, and then you hit the square root button.
Ooh, okay. See, I'm not that high-tech because I've been using my cell phone calculator, but let me try this.
Well, and I am too, but hang on a minute. If you do it, hold it sideways so you've got your parentheses and all those cool functions that you can do. So 113 divided by, and then try doing the parentheses, and then 10, it's 10, and then the square root, and then close parentheses and equal, and then you get 35.7337375599028. And so they just want you to round to the third decimal. So that's how you get the answers that they're getting.
Okay.
So did you get all those steps?
Yeah, what was the actual answer? Let me see if I got the right one. It was
30.
Yeah, I got it. I didn't know about the parentheses.
Uh-huh.
I've been like stopping, going back. So that's
Yeah, don't do that. People get the wrong answer.
I really appreciate that. So, I don't even know how to use a calculator anymore. Okay, so the actual answer that they got was 35.734. 4. Okay, and that's what I got, 35.734. Okay, thank you for that clarification. It's so simple that I've actually been, asking my son. Okay, thanks.
Okay, so that's it for lesson 6, right?
Yeah, that's it.
Yes. Woohoo! Everybody feeling good about that?
Yeah.
Cool. I feel like our first 2 lessons were way overwhelming, so these, like, the next few lessons haven't been near as long, so it's been...
I got
Maybe
everything.
they were trying to scare us away.
Yeah.
Okay,
So nobody dropped the class. Today's the last day to drop the class. Nobody drops. We're all going to make this together.
yay!
Oh, thank you, yeah. So comforting.
So I guess we have to hang up and then start again to do lesson 7?
Do we have to take the quiz though?
Oh, yes.
Oh, yeah. Well then, we're glad you're here. Oh my gosh.
I totally forgot about the quiz.
Totally forgot about it. No wonder we're so happy.
That's funny.
Okay.
Okay,
I'm
lesson
ready.
6.
Lesson 6 quiz, right?
Yep.
Yeah, under the group meeting, right?
Oh.
Okay, here we go. Okay, number 1 and 2, we can all say true.
Oh wait, it doesn't ask us that.
Did you get, I completed individual preparation on number 1?
Oh, I'm on the homework quiz, like the real quiz.
Oh my gosh.
Can you save those ones for later?
I don't think so. Okay.
Open it up in another browser window.
Okay.
Yeah.
And then I'll do that when we're done.
Yeah.
It's not that bad. I already took it.
You already took it?
Yeah.
I should have done that. I finished the homework and everything.
And so I had to get everything done early.
Yeah, no, I don't blame you at all. I gotta like open up another page completely because it doesn't let you go away. Let's see. I was just a little hasty there. Okay.
Okay, so go to lesson 6, group meeting.
Okay, I'm ready.
All right, answer number 1 and number 2 is true. So, number 3, when taking samples of n, when n equals 5, what was the shape of the distribution of means histogram when the parent population is right skewed? I would say right skewed.
Right skewed.
Because it's a low number of samples.
Yep.
Because it
It's
has to
not
be above 10, right? For it to be normal?
30.
30? Okay.
Yep.
Okay, when taking samples of n equals 100, what was the shape of distribution of means histogram when the parent population is right skewed? It would be normal, right?
Yes.
Okay.
Why would that be normal? If you don't mind me asking.
There's so many of them. The n is 100, so if it's 30 or over, no matter what the
amount
is, your distribution of means is going to be normal.
Oh, okay. Got it. Thank you.
Is it you guys? That's the
Number 4.
no. Is it the law of large numbers or the
I think it's the central.
The
Yeah.
central theorem? Okay.
Yeah, the
Central
theorem.
limit theorem.
I'm
Yeah.
just reminding myself. Central theorem. Okay.
All right, when taking samples of n equals 100, what was the shape of the distribution of means histogram when the parent population is normally distributed? Everybody?
Normal.
Yay! Number 6. When would the distribution of means be normally distributed? Choose all correct responses. So the first one, data are drawn from a population that is normally distributed and the sample size is small.
Yes.
Yes. Data are drawn from a population that is normally distributed and the sample size is large.
Yes.
Data are drawn from a population that is right skewed and the sample size is small.
No.
Data are drawn from a population that is right skewed and the sample size is large.
Yes.
Okay. We're almost done. Which of the following gives the best explanation of the central limit theorem? First, if the parent population from which the data are drawn is normally distributed, then the sample mean will follow a normal distribution.
There's cornbread in there.
Second one, for bell-shaped data, approximately 68% of the data will be within 1 standard deviation of the mean, about 95% of the data will be within 2 standard deviations of the mean, and approximately 99.7% of the data will be within 3 standard deviations of the mean. If the sample size is large, the sample mean will be close to the population mean. If the sample size is large, the shape of the sampling distribution of the sample mean will be approximately normal. And I think
D.
that
The last one.
I think it's the last one. If the sample size is large, the shape of the sampling distribution of the sample mean will be approximately normal.
Yeah.
I agree.
Yeah.
All right. Here we go. Let x be a random variable with a population mean of 10 and a population standard deviation of 6. Suppose a sample size of 36 is drawn from this population. What is the mean of the distribution of sample means?
Be 10, right?
So,
I think it's.
so that one, they want to know the mean. So that's the, oh, you can, yeah. Because the sample mean and the population mean are the same for the normal distribution.
And it's not talking about the standard deviation.
Right.
Right. Okay.
Oh yes, Julia is quicker than we all are.
Just because they already did the homework and they asked that question a million times on the homework.
They did.
Yeah.
All right, so what is the standard deviation of this distribution of sample means?
So this is the one where 6 divided by the square root of 36.
Yeah.
Right.
Would it be 1?
It's 1.
Yeah.
Is that what you guys got?
Yes.
Mm-hmm.
It makes sense. 6 over 6.
Mm-hmm.
They want 3 decimal places, so do we do 1.000?
I guess.
Yeah, just in case. One point.
Right.
Mm-hmm.
Number 10. Regardless of the distribution of the population, if the sample size is large, that's greater than 30, what would be the shape or distribution of the sample mean? And I think that's normal. Right?
Mm-hmm.
What theorem would justify your response to question 10? And I think that would be the law of large numbers, right?
It's the law of large numbers.
Yeah.
I thought it was the central.
Yeah, I thought it was central too.
I would say it was the central thing. Oh.
The central limit theorem states that if the sample size is large, the sample mean will be approximately normally distributed. The law of large numbers states that as the sample size increases, the standard deviation of the sample mean will get smaller. So this is talking about the distribution, so it would be the central limit theorem.
Okay.
Right.
Yes.
Submit.
Time to submit.
Submit.
Yay!
Woohoo!
Yay.
Very nice, group.
Yay.
All right.
Right.
I'm going to shut this down and start up another one for lesson 7, and I'll see you all in a couple of minutes.
Okay.
Bye.
Bye.